This is the second example related to motion in the presence of friction force. Okay, I have a block, and the block is sliding on a horizontal rough surface. So this is a rough surface. We have mu k 0.2 and mu s is 0.4 for these two surfaces of the block and the horizontal surface. Okay, it is sliding because of this applied force. The force has a magnitude of 100 Newton. It makes an angle theta equals 30 degrees above the horizontal. Okay, and we would like to know what is the acceleration of this mass. Okay, so this mass m is 10 kilograms, and we are interested in finding how much is its acceleration. I am sure now you are familiar about the first step. First step to do is to draw the free body diagram. Okay, free body diagram means what are all the forces acting on our object. Okay, we have the gravitational force. This is Fg equals mg. It is along the negative y direction. If we choose this to be my positive y, this direction will be my positive x. Okay, and I have the normal force, which is along the positive y. The motion or the acceleration, because my force is in this direction, so the acceleration will be along the surface to the right. So this is the acceleration. Guess what is the direction of the friction force? Friction force will be opposite to direction of motion, because the motion is to the right. The friction force will be to the left. Okay, so Fk will be Fk or Fs. Yes, it is Fk because the object is moving. Okay, so I have to use Fk, the force of kinetic friction, Fk. Okay, and the acceleration is along the positive x. These are all the forces acting on my object. Now, I notice that the applied force is not along the x nor the y axis. So I have to analyze this force. Okay, so it will have x component, positive x component, which is this one. It is neighboring the angle theta. So this will be f cosine theta. And this is the other component, the y component. And as you can see, it is opposite to theta. So it will have f sine theta. Okay, so here I can draw it here. Okay, and this force is F sine theta. Okay, now I can get rid of this force F, not anymore, because now I have its two components. I have its x component, F cosine theta, and its y component, which is F sine theta. Now, I will apply Newton's second law both along the x-axis and along the y-axis. Let me start with along the x-axis. So I would say F net along the x-axis equals max. You can put this vector or you can ignore it because it is one dimension. What are the forces along the x? I have F cosine theta along the positive x direction. F cosine theta, and Fk is along the negative x direction, so it will be negative, equals mass multiplied by the acceleration. So mass multiplied by acceleration. The acceleration is positive because it is along the positive x-axis. Okay, so from here, how many unknowns do I have? I have two unknowns, Fk and the acceleration. So let me call this as equation number 1. Okay, now I go and apply Newton's second law along the y-axis. So F net along the y-axis equals mass multiplied by ay. This is the general form of Newton's second law. Is there any motion along the y-axis? There is no motion, means no acceleration. So this side is equal to 0. what are the forces along the y-axis? I have two forces along the positive y, and Fg is along the negative y direction. So I write it as Fn plus F, this is the applied force, multiplied by sine theta, minus mg. All of this is equal to 0. Or I can rewrite it in such that I have Fn in one side equals mg, okay, minus F, which is the applied force, 100 Newton, multiplied by sine F sine theta. Okay, so plugging in the numbers, we will get a value for Fn. So from here we can find that Fn equals m, the mass, which is 10 kilogram, multiplied by 9.8 minus the force, magnitude of the force, which is 100, multiplied by sine 30. And from here we can conclude that the normal force equals 48 newtons. Okay, so I know the normal force from equation number 2 by the application of Newton's second law along the y-axis. Okay, now I can go back to equation number 1, and I know that Fk equals mu k multiplied by the normal force. This is the normal force, which I know. Okay, so keeping in mind that Fk equals mu k multiplied by the normal force, and the normal force is 48, and mu k is given to be 0.2. Okay, so this will be 0.2 multiplied by 48 newtons. This will result in a magnitude of 9.6 newtons for the friction force. Okay, now I go back to the first equation here. We have F, so I take this equation and I plug the values for Fk, which is 9.6, and the value of F. So from here I can write that the acceleration equals F cosine theta minus Fk, okay, all divided by the mass. And from here we can plug in the numbers, 100 newtons cosine 30 minus Fk, which is 9.6 newtons, divided by the mass, which is 10 kilograms. As a result, the magnitude of our acceleration will be 7.7 meter per second square. This is the magnitude, and the direction is as shown in the figure. It is to the right. Okay, so this is the magnitude, and the direction is to the right. And this is our second example related to the presence of friction in our motion problems. Thank you.